Hello, welcome back student to the design and analysis of algorithm subject. And in the last topic, we saw the optimal binary search tree OBST using dynamic programming. If you did not see the previous video, go and watch the previous video. That is optimal binary search tree OBST dynamic programming. So in today's lecture, we are going to see the reliability design. What is reliability design in algorithm? We are going to see, and we are going to see the introduction to backtracking. Means what is a backtracking and what are the problems can be solved by using the backtracking. Okay, so these are the two topics today we are going to complete. Okay, the first one is reliability design. What is reliability design? It is a problem is to design a system that is composed of several devices connected in series. Example, if I have a different devices connected in series, okay, and every device I have a single device 1, device 2, device 3, go on till device. Okay, take the example of I am recording this video. So I need the device 1 is computer, device 2 I need a webcam, and device 3 I need a mic, and so on. These are all the things I needed. If I have a one device only, if the device is not working properly, then what will be our probabilities? Okay, if we imagine that R1 reliability is the uh, is is the reliability of the device. What is the reliability of device? Okay, how much percentage the device reliability we have? For that, they have a reliability of a function can be given by pi r1. We have a device. If I have if you want to see the reliability 1, then we will have a pi r1. So what will be the R1 reliability for this? If R1 is equals to 0.99, it is almost 1. Is almost 1. If we have one device, then there will be a chances of the damage or something 0.99. And if we have one device, n device, like device 1, 2, 3, so on till n, that is 10. The n device are set in series. How 1 less than or equal to I less than or equal to 10. Okay, whatever the devices you have, below that only we need to check the I as well as the R. Then reliability of the whole system pi r I. So what will be the I? Okay, what will be the I at the end? 10 only. So pi r I can be given as pi r I, the total amount of probability. If we have a 10 device, there will be a possibilities of 0.904. This is a probability, almost 9. Okay, so we are losing 0.1% reliability if we have the devices connected in a series. Okay, the devices are connected in the series, then how much reliability we are losing? We are losing 0.1, 0.1, almost 0.1. We are losing the probability. Okay, for this problem, so if we duplicate the devices at each state, then the reliability of the system can be raised. Okay, like in this example, we all are connected in a series and a single device is connected. Okay, in this we can consider this is first stage, second, third, and so on. Okay, in every stage I have a single device. Okay, so what will be the probability if we have a 10? The probability is 0.904. So for that we are making a duplicate. We are making a duplicate the device at each stage, then the reliability of a system can be increased. Okay, I will show the diagram for this also. It can be said that multiple copies of the same device type are connected in parallel through the use of switching circuit. Example, switching circuit. If the I have a like example, if for taking the class, if I have a mic, okay, if I have a mic, only one mic, okay, so there will be a probability is 0.904 if I have 10 devices. So I can increase to this 3. Okay, I can increase this to 3. Multiple copies of the same device. So how many mics I have now? 3. If you make like this through parallel with the help of while using the switching circuit. Like that, if at each stage there are multiple devices. Okay, similar type of multiple similar type of devices, that is DI. Okay, then the probability that all MI have a malfunction is, with this formula, is very less. 1 minus Ri and Mi. Okay, so for this, what we are doing here, we are making a duplicate device in each stage. And how we are connecting that? With the help of switching circuit. While using the switching circuit, we are connecting the multiple copies of the same device. Then after that, when we have a multiple devices, sometime I have a 3 device, sometime I have 2, 4. Okay, because of that Mi, similar type of devices, this is a formula 1 minus Ri and Mi, which is very less. Let's see here. The reliability of stage I become 1 minus 1 minus Ri and Mi. Thus, if Ri is equals to 0.99 and Mi is 2, even though when we are connecting the two devices, our reliability is still 0.99999, which is almost is equals to 1. Okay, like see, this is a stage 1, stage 2, stage 3, so on, stage n. Okay, stage 1 example, I have this device 1. I have 3 devices of the same device. I have 3 devices. In the stage 2, I have a 2 devices, the same device. And in the stage 3, I have a 4 device of the same type. Okay? So in every stage, as per your requirement, you need to connect with the switching circuit device 1, device 2, device 3. How many devices do you have? You can connect that with the help of parallelly using the switching circuit. If this device is damaged or if it is not working, we can use this device. If these two devices is not working, still we have a one more device to use. Okay, so like this, if you have a multiple copies, then your work will not stop and your probability will be increased. Multiple device connected in a parallel in each stage. Okay, so this is a reliability. So we improve a lot compared to the series. Devices are connected in series better than that. For overcome of series devices connected, we with the help of multiple device connected in parallel in each stage, this will be the best. Okay, in reliability design, we try to use device duplication to maximize reliability, but this maximization should be considered along with the cost. So whatever you are doing, like if you are increasing the devices here, then your cost also will going to be increased cost. Okay, cost will also be increased if you are increasing the devices. So whenever you are going for the maximization, so duplicate devices, so you need to consider the cost. So the dynamic programming solution can be obtained in a manner similar to that used for the knapsack problem, since we can assume each CI cost be greater than 0, each multiple devices must be in the range 1 less than mi less than ui, where ui is equals to c plus ci minus sigma from 1 to n cj of divided by 1. So with the help of this formula, we can calculate the number of devices whatever you are connecting in the reliability. Here, like if you see the difference in the series 1, 2, 3, 4, the cost will be less, but it is not reliability, and the probability is very low compared to multiple device connected in parallel in this is we are considering the stages because we are solving this problem by using the dynamic programming. So what is dynamic programming? Dynamic programming will take the decision in every stage. Example, if this device is not working, so in the same stage, which one is working, it will select that. Dynamically, it will select the device and continue for the next step. In these two device, if any one of device is not working, then we will must have to select the another device by this problem dynamic programming. From these four devices, it will select any one of the device which is working from the stage 3. So this is a dynamic programming. I hope you understand this. Okay, definitely this question will come at least in the 2 marks. Okay, the next one is introduction to backtracking. So what is backtracking? Backtracking is an it is an algorithmic technique for solving problem recursively by trying to build a solution incrementally, one piece at a time, removing the solution that fail to satisfy the constraint of the problem at any point of time. So this is the best. What is this backtracking mean? You are uh, problem. Here we will use the brute force attack to get the success the problem. Okay, to get the successfully the result, we are going to use the backtracking technique, that is brute force attack. So here, if you take the example of the chessboard, in the chessboard, if you can move forward, you can go back, step back. Okay, those who know the chess, how to play the chess, so if you have taken the step one, okay, you go forward. If you need, you can go back also. Okay, so that is technique is a backtracking. And how many types of problems come under in backtracking? Okay, so in the backtracking, we are going. We have an example: 8 queen problem or n-queen problem is, and graph coloring. Okay, graph coloring, Hamilton cycle, knapsack problem, 0 by 1 knapsack problem, sum of subset. This all problem can be solved with the help of backtracking. Okay, but as per your syllabus, you don't have sum of subset. Okay, uh, you don't have 0 by 1, I think. Yes. So as per the syllabus, we will complete. So this all are the things we can solve by the help of the backtracking, but we will solve the problem which is in your syllabus, that we are going to see in our next class. Okay. So these are the things we have completed. First one is the reliability design. Second one is introduction to backtracking. Okay. And this introduction to the backtracking, for the CSE student, the backtracking topic is available in the third unit, and for the IT student, backtracking topic you have in the fourth unit. Okay, these are the things we are going to see the coming classes about the backtracking. I hope you understand this. Thank you very much. We'll see you in the next class.